Hello and welcome back to my channel. Students, as you all know, we are learning organic chemistry through problems. And in this problem series, we have already covered 28 problems, and in these problems, I have already covered general organic chemistry. Currently, we are doing a very important topic, stereoisomerism. So, now let us try to see what is there for us in question number 29. As you see this question on your screen, I will read out the whole question and will explain what it is asking for. There is an optically active compound. So question says that there is an optically active compound and the molar mass of compound is 90. It has optical rotation of 5 degree. So you have made a solution of this organic compound. You have put that solution inside a polarimeter, and once a plane polarized light is made to pass through this solution, it turns the plane polarized light in clockwise direction by 5 degree. The length of polarimeter you used is 50 centimeter. The molarity of the solution which you have poured in polarimeter is 0.8. We have to tell what is the specific rotation. So using all these data, we have to know what is a specific rotation. Before we have applied the actual formula and we have calculated the specific rotation, we will go through some of the basic fundamental details. As you understand, I have mentioned the name plane polarized light. You should first understand what is the meaning of plane polarized light. Student, as you can see from this diagram, there is a light source as we all see in our day-to-day life. From these light sources, we get the light that is unpolarized. So the light you see coming from the light source is basically unpolarized. Now, what is the meaning of unpolarized light? You should understand that as the light is moving, so you can now have a direction of the light movement, there is a line of propagation, and as the light propagates, and as you know, the light has got electromagnetic behavior. What is the meaning of electromagnetic behavior? The meaning is, as it goes in a straight line, electric field as well as magnetic field gets associated with the moving light. And as the light is moving, for an example, in this way the light is moving, so you should understand electric field vectors will be associated in direction perpendicular to the line of propagation. So as the light is progressing like this, the electric field vectors will be associated in all the directions in perpendicular to the line of propagation. So you can see that there are certain black colored vectors coming out from this unpolarized light. These black colored vectors are basically the electric field vectors which are coming out of the light, and these vectors are perpendicular to the direction of propagation of light. So you should understand, in all the directions the electric field is coming out perpendicular to the line of propagation. Now if the same unpolarized light is passed through a polarizer or a polarizing filter, it is a device. The job of this device is, it will absorb all the electric fields except along one plane. Except along one plane, it will absorb all the electric fields from this unpolarized light. So as you can understand, and the plane along which it does not take out the electric field vector, it does not accept the electric field vector, absorb the electric field vector, that direction is called as path axis. And that plane, the electric field vector still oscillate, and except this plane, all the directions the electric field vectors are taken, absorbed by this polarizer. So as you can understand, this unpolarized light, once it passes through this polarizer, you can now see the plain polarized light coming out of this polarizer, and here the oscillation of the electric field is happening just on a single plane. You can see this plane also, and rest all the directions the electric field vectors have been absorbed by this polarizer. Now this is called as plane polarized light. Now what is the job of plane polarized light? Now we will see why we are studying the plane polarized light. The motive is, you can see now this slide. As you can see in this slide, from a light source, unpolarized light is getting created, and as it moves forward and passes through a polarizer, as you all know, it will absorb all the electric field vectors except along one plane, and therefore it will give out a plane polarized light. Now this plane polarized light PPL is now introduced, is now passed through a tube, and this tube is called as polarimeter tube. In this polarimeter tube, you understand, we take the solution of the compound which is under investigation, and what we investigate about is whether this compound whose solution you have prepared, you have put the solution inside the polarimeter, whether the compound is able to interact with plane polarized light in a way that it turns the plane polarized light either clockwise or anti-clockwise. If at all it happens, you watch for the plane of the plane polarized light, and then you keep your eyes once the light is coming outside of this polarimeter tube, and if at all you find that the plane has been shifted either clockwise or anti-clockwise, then you call the compound whose solution you had taken as optically active compound. So the whole arrangement is done in order to know whether the compound you had taken was optically active or not. So it's very important. For an example, once you realize that the plane polarized light has been rotated in clockwise direction, then the compound is called as dextrorotatory, and we put the symbol small d for the optical property of that compound. And if the light is rotated in the anti-clockwise direction, we use the letter L, which means levorotatory, and for the clockwise rotation we use the sign plus, and for the anti-clockwise rotation we use the sign minus. So as now you must have got the clue that the polarimeter arrangement is meant to know whether the compound under investigation is optically active or not. For that, you first create plane polarized light using unpolarized light, and that plane polarized light is passed through a polarimeter tube, and you watch for the plane polarized light coming from the other end. And once you find that the plane of the plane polarized light has been turned either clockwise or anti-clockwise, then we declare that compound as optically active. If it rotates the plane polarized light in clockwise direction, it is dextrorotatory. We put a symbol plus for that and the letter D, small d for that, dextrorotatory. And if it turns the light in the anti-clockwise direction, we use the letter L, levorotatory, and the sign is minus. Now you should understand the next thing. In the question, as we will read out the question once again, the question says that there is an optically active compound. So for sure you are going to get some rotation once the PPL is coming out of polarimeter, and the rotation we have got is of plus 5 degree. That means it is dextrorotatory and the rotation is 5 degree. And the length of the polarimeter is given as 50 centimeter, and as I have already told, in the polarimeter you have to take the solution of the compound. So the molarity of the solution of that compound is given as 0.8. Now you have to tell a specific rotation. Now to tell specific rotation, you have to understand what is the formula we find the specific rotation. So you should understand the formula to find a specific rotation is, this is the way we denote the specific rotation. And what is the meaning of all the things, the subscript, the superscript, I will tell you. The formula is, you record the amount of rotation of that light coming out of polarimeter divided by concentration of the solution which you have taken inside the polarimeter multiplied by, in the denominator, length of the polarimeter. However, you should be very careful about the units. The alpha, as you know, is given in the degrees. The concentration, you must understand, is not molarity. Here the concentration must be specified in grams of compound per ml of solution. So the concentration must not be in molarity. It must be in grams of compound per ml of solution. So in our question the molarity is given. We have to convert the molarity in grams per ml. That we will do afterwards. The length of the polarimeter, again you understand, it should not be in centimeter or meter. It should be in decimeter. So if you are going to convert the centimeter into decimeter, you have to divide by 10. You have to divide by 10. So in our present question, the alpha is given as 5 degree. The length was given as 50 centimeter. But we have to take the length in decimeter, so we have to divide it with the 10. So we have 5 decimeter. Now molarity is given as 0.8. For C we cannot take molarity. So first we are going to convert the molarity into grams per ml. But before we have progressed to find the specific rotation finally, let us see on what factors the specific rotation depends. You should understand the specific rotation depends on certain thing. What is the nature of compound? For an example, you have taken optically active compound, different compounds. As you change from one compound to other, you understand the nature of compound changes. So the specific rotation will change. The next thing is concentration. For the same compound, for the same polarimeter, everything remaining same, if you change the concentration, the specific rotation will get changed. The next is temperature, and the next is the light you are using. If for an example you are using two different sources of light where the wavelength differs, the specific rotation will be different. Normally we use the sodium D line, whose wavelength I will let you know whose wavelength is, as you understand, here the wavelength is given. the wavelength is some 583 nanometer, 593 nanometer, some values there, and the temperature normally we use is 25 degree Celsius. So normally we use that. You may have your own temperature, you may have your own wavelength, own light, but you have to mention which light you are using and what temperature you are operating at. Now coming on to the conversion of molarity into grams per ml. For that you understand, so as you know, we have to know the concentration in grams per ml. So you know the molarity is given as 0.8. What is the meaning of molarity? The meaning of molarity is the number of moles of compound present in 1 liter of solution. So if molarity is 0.8, it means that 0.8 moles of compound is present in 1 liter. That means 1000 ml of solution. So first of all, let us take 1 liter of solution. So the volume becomes 1000 ml. Now in 1000 ml you have 0.8 moles. First of all, we will convert the moles into mass, because here we require the gram. Gram means mass, and you know the formula for mass is moles multiplied by molar mass. The mass is equal to moles into molar mass. So you know the moles are 0.8, molar mass in the question it is given as 90, so the answer is 72 grams. Now the concentration, that is mass per ml, you can find. The mass is 72 gram and the volume was 1000 ml. So per ml, how many grams you have? You have 0.072 grams per ml. Now you are ready with the integrants of all the formula for specific rotation. Now as you know, this is the representation of the specific rotation. You are operating at 25 degrees Celsius and the sodium D line, the wavelength is 589.3. Now the formula is the rotation upon concentration into length. So rotation, as you know, is 5. The concentration we have found 0.072 grams per ml and the length is 5 decimeter. So once you solve all this, you will get the answer plus 13.89 degree. So this is going to be the specific rotation of the compound under investigation. So there are basic conceptual details as we have gone through all those things, and there is a formula, and in this formula you have to remain cautious about the units, how the concentration must be taken in grams per ml and the length should be in decimeter, and decimeter, to get decimeter you have to divide the value in centimeter by 10. So that you should keep in your mind. And a few more problems based on specific rotation of mixture, enantiomeric excess, optical purity are still to come in my future videos. Till then, keep watching my videos and take a good care of your health and happiness. Thank you very much.